Thank you, everyone, for being there. It seems like every presentation is about, we love serverless, but here's the list of things that we want serverless platforms to do that they don't yet do. This talk is no exception. I arrived to serverless from the event-driven microservices processing background, and to that from data integration and database background. So that's kind of how I showed up. By the way of Oracle, MySQL, Hadoop, Kafka, that's kind of where the trajectory went. And when I started looking at serverless, usually as I learn most things, it's through working with my customers. And I kept asking, why do you do this? Why, I mean, microservices was difficult enough. Why do you want to break down your services even more into individual functions? And basically two good reasons. People wanted to not have as much operations. They wanted to scale without thinking about it all that much. And the pay-per-use model is a huge deal. It's a huge deal to the extent that if you don't do the pay-per-use model and you claim you're serverless, I'm kind of skeptical of the whole proposition. But because scaling out without having a person to pay a person to worry about it, and because pay-per-use is so compelling, I think that serverless is the direction the world is going in. You can see we moved to the cloud in order to do less ops and do more pay-per-use and auto-scale and all that. And serverless is just cloud and microservices kind of taken to the extreme. But it is the future because there is still a lot of stuff that I wish we would do. And data handling is a big part of it. So just to level set, obviously, when we do serverless, this is kind of how we imagine it will work, right? Events will happen, a function will magically get invoked, and something will happen as a result. And not less important, when nothing happens, the function will be paused, nothing will get invoked, nothing will happen as a response, and we will not get billed. That's the important part. We also expect that if we have a lot of events happening at the same time, we will have many of those functions invoked without us having to worry about exactly how many and how it will happen, and many responses will happen. So we expect concurrency to somehow magically just exist. We expect concurrency to be magic so much that if you Google serverless scalability, pretty much all you read is don't worry about serverless scalability. Lots and lots of Google results saying don't worry about serverless scalability. So unlike the other rule for serverless, my rule for serverless is just don't worry about scalability, because that's what everyone tells us. Is it actually true? Yes and no. You kind of have to think about some things. So first of all, the different cloud providers scale in very different ways. So if I run 200 HTTP requests, how many function invocations will I how many parallel function instances am I going to get? Well, if it's on AWS, I'm going to get 200 of them. Just up until a certain limit, which is quite high, somewhere in the thousands, it will just magically scale as you would expect. If you're in Google, you will get exactly half the number of functions as you think. So 200 invocations, you'll get about 100 of them. Why? Because Google has a small queuing model. So it will invoke one, and then it will try to reuse them for the second one. And then on Azure, from what I can tell, the number is rather random, and I could make no rhyme and reason of it. And then also, I remember I talked about HTTP requests. But if you have a different source of events, scaling will be different. So we found out that if you use something like Kinesis shards, if I send 200 events to Kinesis, but I have only 2 Kinesis shards, you will only get one event, one function instance per Kinesis shard, and this is up to a certain limit as well. But it's a fairly high limit, so whatever. And I think this is a lot of what the previous presenter talked about, is that you have that much events coming in, but you only get that much instances unless you do this more challenging fan-outs because of this model. And it sounds like, oh my God, why would I want that? That's a terrible, terrible limitation of Kinesis. And when I tweeted whether I found out about that, Some guy developer advocate from AWS got incredibly defensive and like, no, 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 but you can scale out the shards and it's not really our limitation, it's the Kinesis guy's limitation. But to be honest, this is not really a bad thing. There is a lot of benefits for queuing events. First of all, it does add latency, but you know, 99% of the time, some latency is absolutely fine. You don't need 5 microsecond time to figure out what is the weather in, what was it, Portland, Oregon. So this is usually okay. And then one of the nice things is that once you know that you're going to have 2 function instances for a lot of events, you know that those function instances are going to get reused. And this means that you are basically avoiding cold start. It means that you can maintain some state. And it means that the events will actually have the capability of being batched. So you will have fewer invocations for the same number of events, which means that you are actually paying a bit less. All this is very good. And obviously, you can still resort to HTTP if you need a more immediate response, as much as immediate can happen when it's serverless and nobody knows if you'll get cold start or not. But this pattern also looked super familiar to me. I mean, I've been doing Kafka for the last 4 or 5 years. And as everyone who does Kafka know, by the way, how many of you do Kafka? How many of you? Nice. I think more people at the serverless conference do Kafka than do serverless, which is woohoo. Fantastic. So you know that you have Kafka partitions, and you can have as many parallel consumers as you would number of partitions, and then each one of those parallel consumers will just process events in parallel. So it's a super similar model, which is good because it means that I'm already familiar and could give answers to my customer with a lot of confidence. So this is a model that we call hipster stream processing, which basically means that you get an event, you do something with it, and you send out a response. Turns out that you also call it function as a service. And this is really nice, right? It's no matter how you do this kind of pattern, it's stateless, which means that you can really scale it out and scale it in nicely. It's very flexible, and it's very simple to implement. For a totally different reason on the way here, I implemented a small order validation service that gets events, validates them, and sends results out. You'll see me talk about it a bit. And it took me about 2 hours out of my 5-hour flight here. So it's pretty simple to do. And this gives us some kind of like, not exactly equivalent, but kind of similar. So the fast model is kind of similar to what we call stream processing, kind of similar to event-driven design, which means that we can start borrowing patterns from one area to another, which means that a lot of our previous experience with things like big data and microservices is still very relevant. We like being very relevant. Nobody wants to lose their job because they're not smart enough to do function as a service. And it's similar enough that we actually wrote an integration for it. The Kafka Connect has a Lambda connector. It basically gets events from Kafka and invokes Lambda functions, so you can actually use it that way. Now, examples for what you can do in this really stateless model where you just get an event and do something to it, you can do unit transformations. It's in German marks, it has to be in dollars. The German marks still exist. Euros, and it has to be in dollars. You have XML, and you really want to work with JSON. You have JSON, you want to work with YAML. You want to filter some data. There's a bunch of things that you can do. If you have hard-coded rules, this field has to be greater than 0. This field has to be smaller than 500, et cetera, et cetera. And you can also do things like whenever you get this event, send someone an email. So an email service would be a good example. But this is obviously quite limited. And as long as it's stateless, it's obviously very easy to scale in and out. The problem is, what happens once you actually have data, and like non-trivial amount of data that has to be somewhere. Normally, you will store it in your maybe local disk. But hey, it's serverless. The one thing we really don't have is a local disk. So a lot of what we want to do requires state. Examples would be if you have a rules engine, you need to store the rules somewhere. They cannot really be hard-coded inside your function. If you are enriching events, you probably have some data somewhere that you want to join with your events in order to enrich them. You want to check, oh, I have a customer ID, but what is the customer name? Joining multiple events. I got a click, but is this click a result of an email campaign? I have to go and look up another event that may or may not happen. Aggregation obviously requires a state. If you do moving average, you have to store all the events that happened in second 0 to seconds 59 when you get the event from second 60. So all those things require to store the state somewhere. And if you do anything with serverless, you probably do something along this line. You store the state in a cloud data store. And then your function would do select some data that I need from the cloud store, do some processing, and if I need to write something, I do some insert into this cloud data store. And the question is, naturally, which cloud store am I supposed to use? So in order to decide, we looked at some requirements. Obviously, it has to be low latency, because serverless basically means that time is quite literally money. So waiting for hours for the result of the query will absolutely not do. It has to scale automatically, because remember, if I have to worry about scale, I'm not getting the benefits that I expected out of serverless. The whole point was that I don't have to think about scale. That was rule number 1. It has to have the serverless pricing model, right? It has to, want to pay for it when I use it, but preferably not pay for it when I don't use it, or at least not pay for it a lot when I don't use it. And then guarantees are really important, and we always forget about them. And some things are even very well documented. For example, I found out that if I get events from Kinesis, I can lose them because there is no retries. I just found about it about 15 minutes ago. I don't know about you guys. This is ridiculous. Same on the other end. What if my insert into DynamoDB fails? Will I still be able to maintain my function and do all the retries? How will the entire chain work is quite scary. So we need these end-to-end guarantees. So I kind of started looking into the different options. So S3 is probably the most used data store for serverless. Like when I asked people what should I use, this was the most common answer. And with S3, it has the benefits of being probably the cheapest option. It has a very simple data model, which, as we will see soon, is actually a benefit and not an issue. But it has weak guarantees. As you know, S3 is eventually consistent. So if you write something and you try to immediately read it, maybe it's there, maybe it isn't. Very, very difficult to guarantee anything in that state. Aurora, which some people told me to look at, is not serverless. You actually, literally, when you try to buy Aurora, you buy number of instances, the opposite of being serverless. But there is now Aurora Serverless, which is actually quite a good option. It is more expensive on both on storage and on cost per put and per get than S3, but it has a relational model, which we all know and love, and it has the relational guarantees, which we all know and love. So that's not a bad option at all, but more expensive. And then DynamoDB also kept coming up. For some reason, you can get events for Dynamo, but you can also write events for Dynamo. But Dynamo, just like Kinesis, is not exactly auto-scaling in a sense that you create a number of shards, and if you need more shards, you have to go and add more shards, which means that it's a bit extra ops that you may not have expected. So you have all those nice options. I'm going to talk mostly about S3 and Aurora Serverless. Now, we have the data. How do we store the data? How do we model it? And basically, in the first look, serverless looked to me, as someone with data experience, as something that's a bit like OLTP. So my first instinct was OLTP is great for those very quick, fast calls. Like everything has to reliably be less than a few milliseconds. So, and the way we used to do OLTP was third normal form. Basically, break each entity into its own table. And it looked like a good idea, but you have to remember that no matter which cloud database you use, you basically pay for your gets and your IOs. So you really want to minimize them. And if you have a lot of tables and you try to join them, you're increasing the number of IOPS by a lot. So preparing the data in advance to look the same way that you can get it, and ideally a single get will just return to you the object as you need it, is going to save you quite a lot of money in the long run, and also just save you code. So if you have OLTP data model and you need to get some kind of information about a specific order ID 56, you may have to query 3 tables, and they may have indexes, and you may end with something like 6 IOPS on something like Aurora. If you have a denormalized data model, you'll basically be able to do it in one get, and you don't even have to make it Aurora. You can do the same thing in S3. It will just be in this one bucket, and they will be partitioned in some way, and so on. So this seems like a better data model for serverless. But we can actually improve that a bit. I mean, we know that functions may be reused, right? They may be called again and again, especially if we are using something like Kafka Kinesis to queue the requests. So why just, if I'm already doing a get, why get just a single event? It's probably like going to read, especially from S3, it's going to have more stuff in the bucket. Why not read all the orders that are not closed yet, which means that there is good probability that people will check their status. If it's not a huge amount of data, makes total sense. I'll just do a single read, get more information, cache it on my function, and if more people ask for it, I no longer need to read anything from database. It's faster, and serverless Lambda allows you to store things in between invocations. You can have a global state there. So this seems quite reasonable. Or if we want to really scale it out, we probably don't have all the data in a single bucket, and we also don't get requests from everything from the same Kafka or Kinesis shard. So, and we can have expectations, especially in Kafka. You basically know what partition are you getting events from, and it allows you to understand what, if you do partitioning and partition keys correctly, you can actually guess, okay, from this shard I'm going to get specific order IDs. And if my S3 bucketing has this exact same model, maybe because I somehow dumped things from something that's sharded the same way, then I can just go and say, okay, I'm going to read this entire bucket into my function. I know that every event that I'll get to this function instance will be from the same bucket, so I can have a much smaller cache that will include all the information that this specific instance will need. Other requests will go to the other instance. So you can actually kind of maintain your sharding all the way from your queue to your instance to a data store. And this is incredibly powerful. Now, the last really important thing that you are supposed to internalize, think about what I showed you. I showed you how you can create an order and write things to a database. This is a command, right? Create order. I also showed you how you can fetch information about an order. That's a query, right? Tell me about order number 56, please. What's its status? Did it ship yet? This is fantastic. But all of those events, all of those things that happen, they are facts. They are also the fact that someone did something. The order was created. It's a command. Please do something to this order. Please validate it. And it's the fact that, hey, we now have this order. This thing exists. And it's useful to think about this multifaceting of events. And the reason it's useful is because it allows us to implement pretty cool and well-known, well-researched event patterns. So this is going to be a bit complicated because I'm going to tie up all those pieces together. So I'm going to basically build it step by step. The first thing, where do events come from? So I have a shard with the create and update order. So every time I create an order or I make a modification to the order, this is where it shows up. And then I have another shard, and this can actually not be a shard, this can be an HTTP, but I get events with requests asking for status. So we have the commands over here, the requests over there. Separating commands and requests is part of what we call CQRS pattern. So we do that. And we start by taking care of create orders. The first thing we may want to do with create orders is to basically just record the fact that orders occurred. So we kind of use something like maybe Firehose and dump it into a database, maybe let's say S3 or Aurora, etc. But then it's not just a fact, right? It's a command. We have to do something with the order. We may want to validate the order. What does it mean validate? Well, we have rule database, we have inventory, we need to check if the order can be fulfilled, if it's not, doesn't look fraudulent, etc. So we have this VM processing information. And this is the pattern that we call turning the database inside out. Suddenly, this queue of events is at the center, and we use it to build multiple databases. Rather than the old school pattern where the database is at the core and you keep running everything, every query, everything that happens is on the database, you actually put the queue at the center. And the reason this is important is because you can take events from a queue and put them in a database. But using a database to trigger events is something that basically only DynamoDB can do. Definitely not recommended on-prem. Absolutely not recommended if you are old school on-prem and still using Oracle as your database. Using database triggers and something like Oracle is likely to make your DBA really, really upset. So let's avoid that. And then we have the small cache that allows us to save some money on consistent gets. Okay, that's nice. Now we validated an order. What do we do with a valid order? Well, we put it right back in the queue. Now we have an update to the order. It is now not in created state. It is now a valid order. And note that now this update will automatically go to the database. So we're all good here. And now that we have, what do we do with orders that are validated? Well, we ship them. So we can build another service on top that responds to validated events and basically does something, send the package. So we can keep building more and more on top of this single queue. If we have 5 validation steps, we can build 5 validation steps into the same queue. We can decide if we want them to run in parallel or one after another, etc. So we have a lot of power and flexibility in this database inside-out model. Now we get a question. What is the status of my order? Well, another function has to respond to those. Obviously, it needs to know about all the orders. So we read the orders database or a shard of it into our function so we can respond faster. But think about it. Functions these days can be long running, or the function instance can run for a long time. What happens with all the orders that get validated while this is still running? Ideally, in an ideal world, we would keep getting updates. The Kinesis and Lambda architecture will basically keep telling us, hey, you have a new, we know that you're interested in orders. Here's a new update to orders that you're looking at. And this would be amazing, and this is how we build Kafka architectures and have been doing it for years now. Unfortunately, this is not very easy, as in, if you use Kafka, you can kind of do something to work around that by having a side consumer. If you don't, then you're kind of doomed as far as I know. So as I said, because functions as a service is the future, and not exactly right now, we're still missing some important bits to build good architectures. And then once I will add that, maybe we don't need the order database at all. Maybe just having those queuing of events and the ability to cache it, and if my function goes away, I can go and reread the queue. Maybe if only Kinesis would have the Kafka low compaction features that will allow you to compact the queue and only keep the latest state every once in a while, keep everything from becoming too long, that we can do away with some of the databases. So that would be kind of nice. That will definitely save us a lot of money, so maybe it will not show up anytime soon. Now, last thing is that, hey, we have this inventory database over here. Where does inventory come from? Well, if you do the database inside out, you know inventory updates come from a queue. And because inventory updates come from a queue and not directly to the database, you can actually trigger things to happen. You can treat it as data, inventory is data, and it's a command. Inventory update happens, please tell this shop, or please tell the other shop, or please call this customer who has been waiting for something, etc. So this is really the key here. If all you took away from here, other than the small shortcomings of the serverless model, and some price optimizations about caching. If the last thing you take from here is that you can view every event that shows up to your functions as both data and action, and maybe even a query, you can build smarter architectures that do more things with the same event. And that would be pretty much it. If you're wondering what to do next, you download a platform and play with Apache Kafka. You can play with the connector hub, which allows you to connect, to download connectors that connect the Kafka to S3 and to Lambda and so on. You can talk to us about it, and you can ping me. I love discussing serverless and Kafka and event-driven patterns and so on and so forth. I'm, unlike the person who has a dedicated serverless email, I am mostly on Twitter. So feel free to chat with me.
Thank you.